So in this video we will solve problem 15 on the final exam review. So in problem 15 we have three series, and we need to determine if each series converges or diverges. I'm gonna start with the series of 4 to the 5n power over 3n factorial. And notice that because of 3n factorial in the denominator, instead of using comparison tests or the integral test or any other test, obviously alternating series test does not apply here, I will start with the ratio test. If this test fails on me, then I would probably use one of the comparison tests. So ratio test means find the limit as n goes to infinity of a sub n plus 1 over a sub n, and you should get a finite number L, and if that number is less than 1, the series converges. So this is what I need to do, right? So in my case, what is a sub n plus 1? Replace every n with n plus 1. So I get 4 to the power of 5 times n plus 1 over 3 times n plus 1 factorial. And if I simplify this a little bit, I get 4 to the power of 5n plus 5 over 3n plus 3 factorial. And then a sub n is 4 to the 5n over 3n factorial, right? So now we will find the limit as n goes to infinity of a sub n plus 1. So it's 4 to the 5n plus 5 over 3n plus 3 factorial, and we will multiply it by the second fraction flipped. So put 3n factorial on top and put 4 to the 5n power in the denominator. Now I know that in class we did it fast, because usually with practice you know right away what cancels and what stays, but this time let's take our time and simplify this fraction. So first I get 4 to the 5n times 4 to the 5th, right? And then 3n factorial will stay on top. And now in the denominator, I will get 3n plus 3. This is the first term. And now you start subtracting 1 from 3. So 3n plus 2, 3n plus 1. And then at the end, you will have 3n factorial. And what else stays in the problem? 4 to the 5n. Let me write it over here. I don't have enough space. So this cancels, and 3n factorial cancels. So we are left with the limit as n goes to infinity of what? Most of the n's are gone. So I have 4 to the 5th on top and nothing else. And in the denominator I have 3n plus 3, 3n plus 2, and 3n plus 1 left. So now, since 4 to the 5th does not depend on n, it can be factored out, and now I'm left with the limit as n goes to infinity of 1 over 3n plus 3 times 3n plus 2 times 3n plus 1. Now notice that the degree of the top here is 0. There are no n's on top, but there are 1, 2, 3 n's in the denominator. So that means that for the limit we get 0, and the whole thing goes to 0, which is less than 1. So by the ratio test, the original series converges. Okay? So in part B, we will look at the series that has trigonometric function. In this particular case, it's sine to the fifth of n over n to the 7th power. Now, because of a sine function on top, I know that I will use either a direct comparison test, or if it fails on me, I would probably use limit comparison test, or my last resort would be probably the ratio test in this particular case. So we will start with the direct comparison test because of sine function being bounded above by 1, right? We know that the absolute value of sine of n is always less than or equal to 1. So for this reason, you would use direct comparison test. So for b's of n, I will use what? The maximum the top could be, which is 1, and I will keep the n part, the bottom, the same. So now we know that sine to the fifth of n over n7 is less than or equal to 1 over n7, right? But if I throw in sigma, I get to keep the inequality symbol. So as you can see, I've got two series here, and the first series is smaller, well, has the smaller sum than the second series. And the second series converges because this is a p series with n equals 7. So since the bigger series converges, has a finite sum, the smaller series automatically converges. It will have a slightly smaller sum than this series. So converges by the direct comparison test. So if I had cosine to any power on top over n7, I would get the same result, and I would use the exact same series, b's of n. If I had tangent or cotangent or secant or cosecant to do, that would require a slightly different approach, right? Because those functions are not bounded above. They might be bounded below, but not above. Okay, so this series does converge by the direct comparison test. And then we have one more series. So let me flip the page. And in part C of this problem, we are looking at the series as n changes from 1 to infinity, and we have negative 1 to the n power, and then 5n over the cube root of 2n cubed plus 100. So as you can see, this series is alternating series, and also we have a radical which can be simplified. So step 1 is simplify the radical. So the series now becomes negative 1 to the n 5n all over n, because the cube root of n cubed is simply n, as the cube root of 2 plus 100. And now what do you notice? If you cover up the alternating series piece, don't you have 5n over the cube root of 2 times n? So I believe that this series diverges, and all I need to do is to find the limit as n goes to infinity of the absolute value of a of n. And then the absolute value is 5n over n times the cube root of 2 plus 100. And you may use L'Hopital's rule here if you want. This is what lots of you did on test 3. But you can also use the same rule that we used many times before in pre-calculus. Since the degrees match, I have 1n on top and 1n on the bottom. This limit is 5 over the cube root of 2, which is not 0. And we know that whenever the limit of the inside is not 0, the whole series diverges. And the only test for which we use this limit, right, is nth term test for divergence. So lots of you are still confused about the nth terms test for divergence. You think that if the limit is 0, the series converges. No, that's not the case. There are plenty of series, in particular harmonic series, that have the limit equal to 0, yet they diverge. So make sure that you remember that there is no nth term test for convergence. There is nth term test for divergence only. So this series diverges. Now on the final exam, you can see problems that will require ratio test, p-series test and direct comparison test, and perhaps nth term test for divergence. However, I can also modify the problems in such a way that you will not use nth term test for divergence, and instead you will use a root test or limit comparison test. Okay, so be careful. Make sure that besides these 3 problems, you review the other problems that you saw, either on the review or on the second test or test 3. Test 3 only. There were no series on test 2. Okay? So this concludes problem 15. If you have additional questions for me about this problem, please send me an email or see me during office hours on Monday of next week.